This conference will now be recorded.
All right. So yeah, so that's usually why we want to use a straight line lead in on metal, because it is going to slow down more when it comes to a corner like this versus doing an arc in.
Okay.
So it should get fairly perpendicular when it comes to that corner, but it still may be lagging a little bit behind when it takes this corner here. But the other more critical thing happens when you're coming around towards the end, when the top of the stream hits this curve width here. So basically the bottom of the stream will still be lagging behind a little bit, and it kind of jumps across this little bottom area down here, and that's where you get the nib on the backside. So
Okay.
that's why if we can slow down more at the end, like it's doing with these newer feed rates, then it should help to clean that up a bit.
Well, my comparison here is similar parts, virtually the same parts that I've sent to WaterJet service in the past on the first machines that I built using these same components, and those components did not come back with a nib like that. So
Right.
that's the reason that I am continuing to kind of focus on it. Is I know that that equipment did not have them.
Right, and we can certainly get to that point. It's just, every application is a little bit different, balancing cycle time versus quality. So it's just a matter of tweaking things for the particular application. So
yes, sir.
So that,
and I appreciate the lessons on how to tweak it, and not just you guys doing it completely for me from that respect and saying try that without understanding what's going on. I do appreciate the explanation of what's happening.
All right, so again, we'll try again the first one without any TAC. Let's see, so what we should see now is, so we're slowing down to 0.54 inches per minute, versus on, again, the other one we were slowing down to like 1 inch a minute. So we're going half the speed as we're approaching this, and then we're also starting to slow down a bit further away from that end to allow that stream to catch up there.
Okay.
So, let's see how this one looks. So this one here, we start to slow down here. So we go past. These are the Q5 holes. And then on the Q4 holes, then we're slowing down to 0.63. So let's go ahead and process this one. So we'll call this here no TC Q4. New auto, no TC. And then do the other one with that. Auto. Good. So can give those a try and let me know how those look.
Okay. Let me. I'll go ahead and load them. Chris said he would run them for us right quick. Can I pull my USB drive now? Everything's
sure.
Okay. Yeah. How did the VOC part? How did the VOC part look? So we're having to hammer that VOC part out, Mr. Jeff. It's pretty much like it was before. So it's pretty rough. I guess it's rough. I'll try to get it out shortly and we'll see. Hold on for me 1 second, Mr. Jeff, if you don't mind. I'll help Chris move the plate so we can try to get that part out.
Okay.
You still there, Mr. Jeff?
Yes, I am.
All right. So we pulled that part out, and everything looks quite a bit better than what it did the first time. But on the, you can tell the difference in the rough side and the good side, the extra fine. But
So the
I'll try to measure that up.
extra fine side is smooth.
It's smooth, yes, sir. You can see a little bit of striation at the bottom, but the top 2/3 of the part, have a nice, really nice smooth finish without much striation at all. The rough side actually doesn't have very much striation in it.
Okay. Was it the
But it's
tab
got
that
some,
was?
it must have been the way the tab was and how tight the part was, just in general. I don't know if it had some stress in it in the U shape that kind of fit. But I had to tap it all the way to the bottom in order to get it out.
Right. Yeah, I mean that rough quality with those striations, it can make it a little bit difficult sometimes to get things out, but it's good that the smooth side is smoother.
Yes, sir.
Let's see.
Chris has got a call on. If you don't mind, I want to start the machine on
Right.
the test part so it can be running while we're looking at everything else.
Okay. So I'm just gonna delete these other parts here and save this under a different name, just so if we need to, we can. So we've already, I'll just do, let's see here, file, save as, we'll call this test. And I'll just delete these here, just clean this up a little bit. So then, of course, another option you can do once we get good results on the nibs is you could do, most of the hole is like a Q3 and then apply a Q5 quality around the lead in, lead out area to help you.
Okay.
But we'll see how these look at first.
All right. I'm ready for taking a look at a couple other things, if you don't mind.
Yeah. What would you like to?
Let me try to find my art. I think I've got it on my USB drive. So this is a piece of 1/4-inch stainless, and it basically just has two 45-degree cuts, one on either side, for weld prep to make a telescoping tube. Now, what I would like to do is, and I tried to go back through my notes. I know you sent me a video, but I haven't made it through that, is how to add the notches for the bend lines for this particular part.
Okay.
And I also do have a DXF file for this part with those bend lines in it. And what I tried to do was put it in on the 2D side, but then I wasn't sure how to break the toolpath that already existed from the 3D side, so I figured I was mixing two things that I should not when I initially started this part.
Okay. Well, let's exit back to 2D side and bring in that DXF file. And you can use the import. Yeah, there you go. Good.
I got a lot of different stuff now where Matt's been generating some other files for me to try to do tests. Okay.
All right, yeah, so set that off to the left somewhere so we can work with it. Yeah, somewhere over left or right, just off. There we go. Good. All right. Through. Yes, and we were going in 1/10 of an inch.
Yes, sir.
Right. Let's see here. So, yeah, so we can just use, of course, on our CAD, we can do offset or O for offsets. And O for offset 0.1. So we did this. And we did that, and then I offset the vertical lines by 20 thou each side. Oops, that's not what I want to do. Offset 20, and offset this that way, this way, and offset this one this way. And since I'm in here, I'll just trim this up. T for trim. And then this one here, I have to offset that line by 20 the other way. And extend that back. Extend that over there. Okay, trim. And then same thing down here at the bottom.
You keys.
And let's see, get rid of that, and that. Okay, so we got our little notches in there. So now we can get rid of those. And then to make it easiest to work with, you got the join command up here. So we can join all these together as one entity. When you after you select your entities down here at the bottom, it prompts you for tolerance. You can just leave it at 0 and hit enter. So now this will all be one thing. This should make it easier to work with when we go into 3D. So I'm going to use my copy command. I'll just copy this. Did I get the endpoint? I think I got the endpoint to this endpoint here. So, and then I hit escape. So we got our notches in there. So now we can edit the part. Let's see if I get the part. There we go. All right. So on our cam side here, I'm gonna delete the existing outside cuts. Be that one. So just delete that for now. And then on the Tools tab, we have the Import button here. And see if I click on that. So let me just go ahead and, yeah, that would happen here. Let's see, Import. So select objects. So where I got that overlaid there, I can just right click, and if I do quick filter here, should be able, you know, I can filter things down by color. So since that's the white line 7, if I now click on it, I should just get that and not the part like I did last time. Keep original. I usually click yes, just in case I need to edit that again later. So now it's got that in here. And it should all be lined up nicely if I measure from this endpoint down to that endpoint. Our Z is 1/4 inch, X and Y are 0, so that's good. So then to do the toolpath now, we'll be able to pick that as an edge. So of course go to our cam tab, pick our curves, and oops, come on. My mouse is not moving right now. There we go. All right, pick edges, and just to zoom in, make sure I get the right thing. I can click on this. And then I'll just go straight to toolpath and click on plus for new toolpath. And then do you want to start in the middle of one of these edges here to keep things from shifting around when you're doing the bevel cuts?
Yes, that'll be good.
All right, so upper curve. So upper curve will be, I'm going to use this as my upper curve, even though it's on the bottom of the part. But because I have fixed Z, it's going to move it up to the top of the part. So I got my lead endpoint, I just hit enter. The direction I want to go, lower curve, I just hit enter. And then put our lead in and lead out like normal. Oh, I think I screwed up the lead out. Try that again. There we go. All right. So yeah, because we've got
background noise is how hard it's raining here, so I may have to ask you to repeat things. It's just really loud.
Right. So since I've got the tool position moved as fixed Z, when I added that tool path, automatically moves that up to the top of the part there. Now for the engagement right now, it's set to constant. So from a previous one, it was set to 375. So since this is thinner material, we could just change that to 0.25. And when you do that, then those red lines will shorten up there. So,
okay.
So we got the bevel cut on that side and the bevel cut on that side, and then that cut there. So
now, can I ask you something right quick?
Sure.
So one bevel cut, let's see. So my bevel cut, I adjusted that to 375 in order to get that red line to come all the way to the bottom, even a tiny bit past. Is that the right thing to do for that cut?
Yeah, you can do that. If you so yeah, it's gonna go based on whatever that thickness is, which in this case would be 375. The other option is that if this, if you set this from tool to lower, then it'll look at the distance from the green line to your lower curve, and then it'll just automatically figure out what that should be.
Okay.
But that's another way to kind of force it to go a little bit slower if you wanted to. You could use constant, and then, yeah, if you put in a number, like I said, 1 inch, then it's going to use that to calculate the feed rate.
Okay.
So certainly doing that's fine, but if you do tool to lower, then it'll just automatically figure out what that distance is.
Okay.
Tool to lower. So that's good. And then we've got our outside. Okay. I can close that. And then of course we'll have to update our rapids. And okay. Sure. So let's see. Open out. That looks good. Our 0 points at the top of our part, so that's good. So we can create update. And then you got the little slit there. And then I presume we've already done this step in the process. So we've already got that at the top, so that's good.
Sorry, I plugged in a drive.
Yeah, no problem.
Just close that.
Okay, so.
Looks good.
There you go. If you want to go ahead and make that file, you can.
Now, do I need to uncheck paper comp if I did not have paper comp checked initially?
Well, it's not, yeah, if that is checked, since we didn't tell it that we want to taper comp any of the cuts, it won't put the taper comp on there.
Okay.
So you can leave that, yeah, you can leave that on pretty much all the time, and then it's only going to apply the taper comp to the ones that you specifically told it to taper comp.
Okay. Okay. Another question that I have, because we did some 45-degree cuts in this 3/4 inch material, was, and I believe I saw a video or heard someone talking about it, telling me some information. That is, it's better to do a vertical pierce and then lean the head. and then lean the head into position, or is that not, doesn't really matter?
The issue that you can sometimes get with the this Apex 60 head, if you do stationary piercing or vertical piercing and then tilt over, is that we can get into a singularity thing, and it'll want to spin around as it's doing that lead in if it passes through the anywhere between the C of -90 and -180 and A of -10.
Okay.
So we're recommending that people do tilted piercing with the Apex 60 head.
Okay.
So yeah, I would go with that.
And I created a part. I think it had a lot of taper comp holes in it and one bevel. I was able to fix it, but it came up, you know, when you get through the process and you generate the file, it tells you how many rewinds and other things, and also brought up a singularity error on a particular line.
Right.
Will it run through that singularity error, or is it like on a 6-axis robot, if you program through singularity, it's going to fault out? Is this going to have a fault, or would it work its way through it and just leave a little imperfection at that area? What exactly happened?
Yeah, it'll basically, as it's cutting along, if it hits one of those points, the cutting head will just like spin around 180 as it's cutting. So you might see a little bit of a divot there where it spins around.
Okay.
I believe they told me last week they had done something in the kinematics where if it, or was that only on the negative A's? I guess that was only on negative A's. They did something where if it ever saw anything that was negative A, it just automatically went over to positive A. But yeah, if it passes through one of those singularity points, it'll just be going around. It'll just do a 180 as it's going along.
Okay. So for the most part, nothing really bad happens. There's not going to be a crash or anything. Okay.
No, yeah, just again see a little ding there where it's spun around.
Okay. Well, the same thing with the rewinds.
Well, rewind, it'll stop, and then it spins around and it comes down and re-pierces. So again, you'll see a little bit of a witness mark there where it re-pierces.
Okay. I'm getting the whole test part out. Looks like they're starting to get better without the paper comp on the Q5 side on the left-hand side of that part, or the right-hand side?
I think
it was the left-hand side.
Yeah, because the right towards where we had the tab was Q4. Might have. Let's see. So they look a little bit better.
Yes, sir. I'm going to start the with the paper comp program. Let it start running. Sit down so I can look at the drawing and make sure I don't tell you anything backwards. I thought I loaded both parts on the machine. I got to get my USB drive again. There it is. So when I leave the tab on our right-hand side, like we're looking at that page, the hole on the far left, I would say, looks the best. And then the next two holes are very similar. One has just a tiny bit more pronounced little nib left, but the one on the far left basically has nothing there. Get my calipers to measure the.
Right.
I'm at 690 on the top and 688 on the bottom, so it's about 2,000 difference.
That's pretty good. All right. Okay. So does that look like a good hole to you?
I'm sorry?
Does that look like a good hole for you?
Yes, sir. I think that'll be okay. I can't see how that would affect the tap or anything else.
Okay. Let's see. I think my internet connection's bogging down here. There we go. Let's see. Oops.
It's probably because of how it's raining here.
Yeah. So, yeah, I mean, so if you wanted to try to take that any further, you could, reduce this a bit more. If we change this deceleration distance, it'll start slowing down further from the end, which is probably why the second and third hole might have looked progressively a little bit more, because it's always looking at the end of the lead-in point. So as we're moving our over travel by 20 thou each of those, then that's essentially moving that slowdown point 20 thou closer to here. So like if we were to change this to say 0.125, and
so basically less overcut on, or there's a fine line of having the correct amount of overcut on the hole.
Yeah, because if you get too much overcut, then your slowdown distance is going to happen too close to where the lead-ins is coming in, and it's might already travel over where it led in. So in some of these other parts that we've cut, we might want to, you might need to go back, or just in the future use a little bit less over travel.
Yes, sir.
So let's see here. Turn off. 9265. That was that hole. 9265. Thought that would have changed that. Let me see. deceleration distance inner. You would think that that's what that would have been. Set that back to default for a moment. It's not going to be that. The other thing you can also adjust is this arc factor. So it's basic algorithm that the smaller the diameter of the hole, the slower it's going to cut it. And if you wanted to force it to cut them even slower, this arc factor would adjust that. We'll take a look at that in a moment. Let's see.
So making that smaller, making arc factor smaller, cut slower.
Right. So right now, let's see here. Let's look at that. So, because right now, if we look at this hole, we max out at 1.49, and if we let's go edit, set this back to default. So if we go 0.5 for fun, okay. So now it's doing 1.29 versus 1.49 before, so it's going to cut a little bit slower for most of the cuts. So it still slows down to the 0.54 that we had at the end there, but the high speed isn't quite as high.
Okay.
But that's just another parameter you could adjust if you needed to. But we'll go back to what we had. And default. All right. So, good with that for now?
Yes, sir. And some of what may have been happening, we've had trouble with abrasive flow and other things. That seems to be getting better now. And I'm not sure if we didn't have a shortage of abrasive on top of some other issues happening along the way. So, so far, so good today. We've seen a lot of improvement and haven't seen the intermittent abrasive flow that we saw past couple of days. And I think we may have been seeing it last week. We just didn't realize that's what was actually happening.
Right. How did this hole here look like? That was the 20 thou with the Q4.
Of the three holes, of the three Q4 holes, it is the best. But I can, from a foot away, visually see that nib. But the nib is not as bad as what they were previously.
Right. Yeah. So then, as I say, you could go through, and if you wanted to cut most of that cut at Q4 or the fine, and then you could say, all right, let's do Q5 from, like here to here. You could do something like that also, where you could, that way that would help a little bit with the cycle time, but still get good lead-in quality at that point.
How would you approach that if the part was created in the 3D 5X?
We can still do that in 3D 5X. So if we, let's see, actually, sorry, let me exit. Let me make a part out of this first. Sure, we'll just set this to, we'll leave it there for now. All right, so we go 3D 5X and import this, keep original, yes. Curves, pick surfaces. I'll just pick tops. Yeah, I'll do top. All right, and then toolpath, and let's see, since this is 3/4, 0.75, so let's do a little bit less. So I guess this will be interesting if we try one of these like this, 020, and let's not do any lead out. A little bit longer here. All right, plus. And endpoint, direction, lower curve, nope, in, and, all right. And then we'll just do that for the other ones, auto. Oops, wrong, so close. So close, random click there. Let's move that there. Okay, reorder that. All right, so if we look at quality, let's set that one to extra fine. Set this to extra fine. Set this to, sorry, extra fine. And then on the next three, we'll set this to fine. And then if you click on this little arrow here, then you can come in and say, all right, let's go extra fine from wherever you're.
Okay.
Let's try that on the other ones here. Change this to fine and extra fine from here to here. Okay, we got that. And then do our outside cut. And direction. And lead in. And let's see, lead out, but we'll have to make this minus 0.020. Okay. So I will just do that as medium. All right, so we got that. Okay. And set our rapids. Set our 0 point. Create. Cap locks is on. All 3D X. Okay. Let's see. Sorry, let me go put taper comp on the holes. Bad. Yeah, might as well do it on the outside. Okay. 1.09, 1.49, slowing down to the 0.54. Okay. So let's see. Test tools Q5 new auto 3D 5X no TC save. If you find that you're never using this box, I can make that go away again.
I'm sorry, which box? I was getting the part out.
Yeah.
I didn't have my eyes on the screen.
If you find that you're never using this custom stuff box, I can make that go away again.
Okay, I don't have a problem with it that way. If I do, it's a good reminder for me that there's other stuff available. So when I run into it, I can read in the manual, give you a call or something, see what we need to do to be able to utilize it.
Yeah, I mean, primary benefit of this one is if you ever do want to use a work offset position to easily be able to
yes, sir.
choose that. So.
Okay.
All right, so that's that one, and then do it again, this time with the TAOC. With TC. 688 test Q5, Q4, new auto 3D 5X with tape cop. Good. All right, so there's a couple more parts for you to play with.
Okay.
Good.
Stop doing it. The taper comp version of that part probably had a little bit more nib on it, marginally.
Mm-hmm.
Still a lot better, but it had visually has a little bit bigger nib.
Right. Considering we only had 2 thou taper on the non-taper comp hole.
That's pretty good. The taper comp hole is actually measuring about 2 thou different as well, but it's 5 to 7 thousandths big, 3 to 7 thousandths big, 3 to 5. Hold on, maybe I don't have my 693, 696. And then the non-taper comp hole, 691, 688.
Right.
So it looks like the non-taper comp hole actually did better.
Yeah. So on that taper comp hole, 693 at the top, 696 at the bottom. So it's actually a little bit bigger at the bottom. Which means it's basically kind of like overcompensating a little bit too much for the anticipated angle on there. But since we're only getting 2 thou taper anyways, that's probably why it's doing that. So.
Okay. Okay. So I probably need to run that part over, the taper comp part, test part over again, and input some new numbers now that we've got Garnet running better and some of the other things that we worked through.
Right. Well, yeah, so it would be interesting to see now this one here that we did with the 3D 5X, how that one looks like. So that one should be on your D drive there now, or is it on the C drive now? I guess probably on the C drive.
It should be on D.
On D? Oh yeah, there they are. Right. So.
3D 5X. So I need to run those two programs and check those out. Okay.
Yeah. Yeah, interesting to see if there's any difference between the 2D version and the 3D version.
Okay. All right, I'll try to do that.
Okay. Anything else you want to go through?
I think the main thing was I needed to see how to put my notches in for bend lines one more time in both systems. So hopefully I've got that more or less under control now. At least I can take off with it again and try again.
Right. Okay.
All right.
Good.
Thank you, Mr. Jeff. I appreciate it.
Yep. Have a good day.
You too, sir.
Thanks. Bye.